Hello, in this video we will be going over the sorting algorithm merge sort, its characteristics, a demonstration, and the code implementation. Merge sort begins by breaking the array into halves, and depending on the size, it will break those halves into fourths and so on. Merge sort is a recursive algorithm, which means it does this all very quickly. After breaking the list till there is only one element in the numerous arrays, the program will quickly put the list back together while comparing. As you will see later in the visual demonstration, this is very easy for merge sort since the arrays are in small lists. As you can imagine, the complexity of merge sort is big O and log n. This means that the runtime is very fast, making it ideal for large amounts of data. And here's the algorithm. As you can see, on line 8 and 9, we have the recursive calls for merge sort. On line 12, we have the actual merge call, which will merge all of the singular list back together. Moving forward, we have the visual demonstration of what happens. I is set to the beginning, j is the midpoint, and k is the end. With this, we can then separate our list. We have from I to j and j plus 1 to k. These will be our left list and right list. Next, we have a more visual demonstration to see the entire tearing apart of each list. Here we begin with the same thing that we did earlier. First, we will break off the left list. Then we will break off the leftmost of the left list. And then we'll break the left list again. This means we now have 2 finished arrays. We do the right of the left list, and now we have 4. Moving to the right side, we break the left side of the right list. Finish it off that, move 3 down since it is the only value in there, and now we have all of our arrays. This is the divide part of the divide and conquer method that merge sort uses. Next, we'll be looking at the conquer side, or the merge side. And here's the conquer part. I know it seems like there's a lot going on at screen right now, but it's all going to make sense here in a second. First, you can see we have our left position on the left, and our right position, the k, and the merge position. This means the first thing that we're going to do is initialize. Next, we're going to create an imaginary merged list. This will be what holds the 2 merged values as we merge each list together. The merge list array will be in the bottom left corner. Now that we're all set, we can begin on the code. We will start on line 8, where we have a while statement. The while statement reads, while left position is less than or equal to j, and right position is less than or equal to k. Next, we're going to focus on line 8, which is a while statement. Inside of the while statement, we have left position is less than or equal to j, and right position is less than or equal to k. As of right now, we can see that left position is 0 and right position is 1. We know that j is equal to 0 and k is equal to 1, meaning that this while statement is true, meaning the boolean is true, and we can continue with the code inside of it. The next is an if statement. You can see on the if statement on line 9 through 12, we have the first if. The if statement says, if list at left position is less than list at right position, then the merged list at merged position will be equal to the list at left position. We would then increment left position and then move on and increment merged position. However, that is not the case. As you can see, right position is actually less than left position, or the elements that they are holding. This means we will execute line 13 to 16, which means the merged list at merged position will be equal to the list at right position, and then we will increment right position. The code execution will look like this. 15 will move, and right will increment. After that, on line 17, we update merge position. Next, merge position on line 17 will update, and we are done for that iteration. Since the system knows that left position is greater than right position, it's going to automatically put it behind that right position, meaning 23 will travel down, and everything will move over into the next array. Now we have the same process. We check the while loop. Seeing that it's true, we then check left and right position. In this case, left position is less than right position. So that means the merged list at merged position will be equal to the list at left position, or 1 will go to the first spot in the merged array. 15 will follow, and we now have our sorted parts. Now we can move on to the next part, which was the right list. Starting off, we make the merged list. Now we check the if statement, or is left position less than right position? And in this situation, it is not, meaning that we will be using the else statement. This assigns 8 to the merged position, moves right position, and now merged position will move. Now we bring 30 down, and everything moves to the next list. Here there's not much the system can do. We check the while loop, and see that it is false, meaning that 3 will end up in its own array. Now that you understand what the combining looks like, we can move on to a more generalized picture of it. Here you can see the list that we just made. We have I and j to designate where we are, and then we can begin the comparison. We place 15, or I, and j. Then we ask ourselves, is 15 less than 1? False. This means 1 will move down to the merged list, and now j increments. Now the next 15 will come down, and we will check, is 15 less than 15? Not really. So the boolean is false, and 15 moves down. And We already knew that at position I, the element was smaller than at the next position, or I plus 1. This means 15 will move down, I will increment, and 23 will follow, since the system already knows that 23 is greater than 15. Now I and j move, and we have, is 8 less than 3? False. This means 3 will move to the first spot, j will follow, I will increment, and 30 will follow. We are now moving into the final part, but we just need to sort these last two lists. We have j and I already initialized, so we can begin. We have position I come down, and position j come down. Or, is 1 less than 3? True. This means I will go down, I will increment, and we will bring 15 down. Now we check. Is 15 less than 3? False. This means 3 will go down, j will increment, and 8 will go down to the if statement. Now we have, is 15 less than 8? False. This means 8 will go down, j will increment, and 30 now joins us at the if statement. Now we have, is 15 less than 30? True. 15 will go down, I will increment, and the next 15 comes to meet 30. Now we have, is 15 less than 30? True. 15 will go down, I will increment, 23 follows, and now we have, is 23 less than 30? True. This means 23 goes down, and 30 follows. Now the array is sorted. Next, we'll move into the coding implementation. First, I'm going to create a class. Then I'm going to save it to my directory, and now I'm going to create the main. Here, I'm going to create the array. Merge sort is made of two methods. This means I'm going to go ahead and create the first. This method will be called merge sort, and the other one will be called partition. I've decided to shorten the name to merge. The parameters merge will take is the list, the starting index, and the finishing index. Now we will make an int j, and j will be equal to the midpoint, which is found, and if I is less than k, then we will assign j to the midpoint, which is equal to I plus k divided by 2. Now I'm going to create the recursive calls for the left and right side. It'll be the array I and j, since j is the midpoint. Then for the right, I will have from j plus 1, so j not including itself, to k, which is the ending point. Now I will call the merge, which will merge them together. I was actually wrong. This method will be called merge, and the other one will be called merge s, since it is merge sort. Now to create the actual merge method. As you can see, I haven't added any parameters yet, and that's because I'm going to define them right now. This method will take the array, as well as int I, int j, and int k. And as you remember, int I is the beginning, int j is the midpoint, and int k is the end. And now we're going to go step by step on how to create this merge. First, we are going to find the merged size, or the size of the merged partition. The reason that we can find the merged side this way is because k is the largest and I is the smallest. This means if we have an array list starting at 10 and ending at 5, we will have 5, but since array lists start at 0, we add 1 so that we include that extra area. I will label these so that we don't get confused. This will be the size of the merge. Next, we're going to create a list with that size. We will now create the merged position, which will hold the index of the next merging spot. And next, we will create the left and right position. Now that that's done, we can assign them their numbers. Merged position will be equal to 0. Left position will be equal to I. And right position. Right position will be equal to j plus 1, since it starts after the midpoint. Next, we're going to create a while loop. This while loop is going to add the smallest element from left or right partition to the merged numbers, or the merged array. Inside of the while loop, we will have an if statement. This if statement will decide whether the list at left position or the list at right position is lesser. If this is true, the merged array at merged position will be equal to array A at left position. After this, we're going to move the merged position forward, simply by incrementing it. However, if this if statement is not true, then the merged array at merged position will be equal to array A at right position, and merged position will still move. I had these wrong. It would be left position moves, and right position moves. My bad. The merged position will only increment after each of these, which means outside of the if statement. And now we're going to create a while loop, which will check if the left position or the right position are empty. That means outside of the other while loop, we're going to create them. This loop will run while the left position is less than or equal to j. This is because once the left position reaches j, it is no longer the left position and will become the right position. Merged array at merge position will be equal to list array A at left position. After this, we can increment left position and merge position. The reason that we put the double plus before is because it is a post addition. This means after it, we add on. Next, we will pretty much just copy and paste this for the right side. However, if you're going to do this, do make sure that you go through and check everything is correct for the next side. After this, we just need to copy the merged positions back to the original array. This will be a simple for loop, setting merged position to 0. Merged position must be less than merge size, and plus plus merge position. Then on the inside, we will have array A at I plus merge position is equal to merged array at merge position. With that, we can now call the method in the main. We will call merge s with the parameters array A, the starting point 0, and the ending point A dot length. Dot length minus 1. And now we need to make sure that we fill in this merge. We will pass array A, int I, j, and k. With the call, the last thing we need is to print. Remember to move the ln so that they're on the same line. We have array at I, concatenated with a space, and a system out print to eat the last line. Now, if everything looks just about right, we can go ahead and save and compile. And now we can run it. As you can see, I have an error on line 25. Okay, there was 2 errors that I resolved. First, I forgot to include the recursive calls to the left and right, as well as the merge call within the if statement. Then, I made the same mistake I told you not to make. When I copy and pasted, I changed everything except for the j here. That caused an issue of me losing numbers. So I changed it to k, which is what it's supposed to be, and now we can compile it and run it, and there we have it. The array is sorted. Merge sort is very effective, very fast, and works great for large amounts of data. It does take a little bit more time to set up, but it is definitely worth it. I hope this was helpful, and happy coding.